I will be showing you an interesting number theory problem and I'll also be showing you its solution. So let's get into it. Now before I show you the solution to this, I need to tell you about a logic. The logic is, suppose you're trying to prove that x equals to y. Then you'll have to say that x will have to leave the same remainder when suppose x is divided by a number n, same as when y is divided by a number n. And n here can be anything. Suppose n is 2. So the only possible remainders are 0 and 1. And if suppose x leaves remainder 0 and y leaves remainder 1, that would mean y is odd and x is even. That means they can't be equal to each other. And that is somewhat of the logic we'll be using today in our video. Okay. So what we'll do here is take 3 power x minus 2 power y equal to 1 and apply mod 3 on both sides. Now since 3 power x is always divisible by 3, we get a remainder 0 here. And for minus 2 power y, we can write that as minus 1 times 2 power y is equal to 1 modulo 3. And we can write the minus 1 as 2, adding 3. So you get 2 to the power y plus 1 is congruent to 1 modulo 3. Now we try putting in some values. So let's put in y equal to 0. So we get 2. Y equal to 1 we get 4. Y equal to 2 we get 8. And we get 16 and we get 32 and we get 64. Let's just try taking some remainders and see what happens. We get remainder minus 1 here, or say even 2. Here remainders can be negative. Let's just take 2 for a good number, as we all are used to. We get remainder 1 by 4. We get remainder 2 by 8. Remainder 1 by 16. Remainder 2 by 30. And remainder 1 by 64. And we kind of guess that it's a looping pattern. It alternates 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. And hence, we make the guess that since this is 2 power 2, y plus 1 will have to be even. That is 2m, where m is some integer. So y is equal to 2m plus 1. And now we substitute this into our original equation, getting 3 to the power x minus 2 to the power 2m plus 1 being equal to 1. And we get 3 to the power x minus 2 times 4 to the power m equal to 1. We take modulo 4 on both sides, getting 3 to the power x is congruent to 1 modulo 4. And here we take the same process again and try to check the values. So we take x, so we get 1 when x is equal to 0, and we get 3 when x equal to 1, 9, 27, 81, and maybe going a bit overboard, we get 273. And we take remainders when divided by 4. So we get 1 remainder here, we get 3 here, we get 1 here, we get 3 here, we get 1 here, and we get 3 here, and so on. And we kind of again guess that it's an alternate repeating cycle. And with that, if we consider that, x will be even. That means x is equal to 2n for some integer. Now we put that again in our expression, in our equation, and we get 3 power 2n minus 2 times 4 to the power m equals to 1. Now here, since this was originally a power of 2 times 2 to the power n plus 2n plus 1. We write that as original and we take 1 to the LHS and we take this expression to the RHS. We get 3 power 2n minus 1 is equal to 2 power 2n plus 1. Now here we can factorize this. We get 3 power n whole square minus 1 whole square. So we get 3 power n minus 1 times 3 power n plus 1 is equal to 2 power 2m plus 1. And now we see something very interesting. We can apply the logic. Just forget this 3 power n for 1 second. And we just see that this and this have a difference of 2. And the right hand side is 2 power 2n plus 1. That means these two expressions are both powers of 2 different by 2. And the only case that can happen is 2 and 4, where 2 is 2 power 1 and 4 is 2 square. There is no other case where there are two numbers different by 2, both being powers of 2. And hence, with this logic that it is 1 and 2, we get our solution to our equation 3 power x minus 2 power y being 1, 1, also 2, 3. And these are our sets of solutions. Hope you guys enjoyed that interesting number theory problem and stay tuned for more. Bye.